Binomial distribution. In this video, we will discuss random variables, which represent the outcomes of random events, the Central Limit Theorem, which states that the means of large samples become normally distributed, and the binomial distribution, which counts the number of successes in fixed, independent trials with two possible outcomes. A random variable is a variable whose value can change across repetitions of a random experiment. It represents a numerical outcome in a probability distribution. A discrete random variable has a finite or countable number of possible values, while a continuous random variable has an infinite number of possible outcomes, often represented by intervals on a number line. Discrete random variable represents countable outcomes, such as the number of pink marbles in a bag, typos on a page, or heads in a coin flip. Continuous random variable represents measurable quantities, like student heights, the amount of lemonade in a jug, or the time to complete a race. A binary variable has two possible outcomes, such as male or female and yes or no. To transform a random variable into binary, outcomes are categorized as success or failure. For example, rolling a six-sided die can be made binary by defining a roll of 3 as success and any other number as failure, resulting in the two outcomes, 3 and not 3. A random sample is a subset of a population where each member has an equal chance of selection. It accurately reflects the population, minimizing bias and ensuring reliable statistical analysis. A statistic is a numerical summary of a characteristic of a sample, such as the mean, median, or standard deviation, used to estimate or infer properties of the whole population. Central Limit Theorem states that if you plot the means of more data sample sets, you will end up with a normal distribution regardless of the initial shape of the population distribution. Central Limit Theorem states that as the sample size increases, the distribution of sample means approaches a normal distribution, regardless of the population's original distribution. The key equation for the Central Limit Theorem is given, where z is the standard normal variable, x bar is the sample mean, mu is the population mean, sigma is the population standard deviation, and n is the sample size. Central Limit Theorem states that the distribution of the average score from multiple dice throws will approximate a normal distribution as the number of throws increases, regardless of the original distribution of individual dice scores. For example, if you roll a die many times and calculate the average score for each set of rolls, the distribution of these average scores will tend to form a bell-shaped curve, normal distribution, as the number of rolls per set becomes large. As of 2018, the distribution of average life expectancy in the world is not perfectly normal but rather left skewed. This means that most countries have higher life expectancies, with fewer countries having significantly lower life expectancies, causing the distribution to skew toward the left. Let's take samples from the population by selecting 1000 subsets of size 150 and plotting the distribution of each sample's mean. This process is known as the sampling distribution, and according to the Central Limit Theorem, any sampling distribution derived from any population will exhibit a normal distribution, regardless of the original population's shape. Binomial distribution is a discrete distribution characterized by two possible outcomes, success and failure. It applies to experiments with n identical trials where each trial results in either success or failure. The probability of success remains constant across trials, and the trials are independent of each other. For example, it can be used to find the probability of getting exactly 3 heads when flipping a fair coin 5 times. Bernoulli distribution is a special case of the binomial distribution with only one trial, representing a single experiment with two possible outcomes, such as flipping a coin once. In this distribution, the probability of success, getting heads, is 0.50, and the probability of failure is 1 minus 0.5 equals 0.5. Expectation refers to the average or mean value of a random variable x over many trials, while variance measures the spread of x around its mean, indicating the variability of its values. In a Bernoulli distribution, the probability of success is 0.4, while the probability of failure is 0.6. Probability density function for a binomial distribution can be used to determine various statistical measures. For a probability p equals 0.4, the expectation a, x, is equal to p, which is 0.4. The variance var x is calculated as p multiply 1 minus p, resulting in 0.4 times 1 minus 0.4 equals 0.24. Binomial distribution models the number of successes x in n trials, where each trial has a success probability p and a failure probability q equals 1 minus p. It is used to calculate the likelihood of achieving exactly x successes out of n independent trials. In a quiz with 10 multiple choice questions, each having 5 possible answers with only one correct, Ali guesses on each question. The probability of Ali getting exactly one answer correct is 0.2684 and the probability of getting all 10 answers correct is 0.00000001. Where both answers calculated using the binomial distribution formula. Given that the probability of a baby being born male is 0.51, and a midwife delivers 10 babies, the probability of exactly 4 babies being male is 0.197, while the probability of at least 8 babies being male is 0.0621. Where both answers calculated using the binomial distribution formula. In a college where 20% of the students are girls, the probability of having at most 2 girls in a random sample of 5 students can be determined using the binomial distribution with 5 trials and a success probability of 0.20. By calculating the probability of having 0, 1, or 2 girls in the sample, the result is 0.94208. When cross-fertilizing red and white flowers appear 25% of the time. If we cross-fertilize 5 pairs of red and white flowers and produce 5 offspring, the probability of having no red-flowered plants among these offspring is 0.237. Cross-fertilizing a red and white flower yields red flowers 25% of the time. When crossing 5 pairs of red and white flowers to produce 5 offspring, the probability of obtaining 4 or more red-flowered plants among these 5 can be determined using the binomial distribution, which results in a probability of 0.016. An FBI survey indicates that 80% of property crimes remain unsolved. In your town, where 3 property crimes occur independently, the probability of at least one crime being solved can be determined by calculating the complement of the probability that all 3 crimes go unsolved. For a roulette wheel with digits 09, each having a probability of 0.10, the probability of getting the digit 5 or 6 exactly 3 times in 20 spins is calculated in case 1, while case 2 determines the probability of getting a digit greater than 6 at most 3 times in 20 spins. In case 1, the probability of landing on either 5 or 6 exactly 3 times in 20 spins is 0.2054. In case 2, the event involves landing on 7, 8, or 9 with a probability p equals 0.30. Given n equals 20 spins, the number of such outcomes follows a binomial distribution binomial, n equals 20, p equals 0.30. The probability of this event occurring at most 3 times is the sum of the probabilities of it occurring 0, 1, 2, or 3 times, which is equivalent to p, x is less than or equal to 3. In case 2, the probability of landing on digits greater than 6, specifically 7, 8, or 9, at most 3 times out of 20 spins is 0.10709. Thank you for watching.